Thank you so much for inviting me along today. It's been a delight to be here. And I must say, I really enjoyed the whole day, and particularly the session this morning. I mean, how exciting. I mean, I think there's 15 of you in this room here, all starting out on a 3-year program, I guess, to do PhDs. I've had the odd engineering doctorate work with me, and I know the value you get from an individual who focuses on waste in this particular case. So, you know, what an exciting 3 years ahead for you. And listening to the things you talked about, you had all the touch points, and all the things that would be of interest to me in terms of sustainability and circularity you mentioned, so it got me really quite excited. So I do wish you all the very best for the future on this programme, because it is incredibly exciting. So today, I could actually stand here literally all day and talk about waste, but you'll be very pleased to know I'm not going to do that. I thought just a couple of hours would be plenty, so no, it's just 30 minutes. But what I'm going to talk about is a little bit about Rolls-Royce PLC, just to put things in context as to what it is that I work with every day. Then our environmental targets. We've got global targets that we've set in the public domain for about 15 years now. And then particularly around our waste action programme. And as I go through that, I'll try and pick up on some of the comments that have been passed today. We'll just give you a perspective from an industry, a manufacturing engineering industry, as to the sorts of waste we deal with and the sorts of approach we're taking to try and reduce the amount of waste that we generate. And it's not easy, it's a very difficult process. I want to show you, hopefully, a video on Revert. That's why we're delayed starting. Just to show you what is really our very best example of circularity within the company, and also talk a little bit about drivers and challenges. If you want to ask me anything as you go along, please do wait to the end, whatever you want to do. If at the end there's something you would really hoped I would have said and I haven't said it, then please ask me that as well. I'm very happy to cover whatever. So a bit of context then. This is Rolls-Royce PLC. We don't do cars, okay? So everybody always asks me, do I have a company cars or Rolls-Royce? No, I don't. Rolls-Royce cars was sold to BMW about 15 years ago. So we don't do cars anymore. We are 3 main businesses: our civil aerospace, our power systems and defence. Civil aerospace is the dominant business, so gas turbines, you know, we all fly around, you all got engines on wings. About more than half the engines on the transatlantic sized jet will be a Rolls-Royce engine. So that dominates our thinking. So although we're about lots of other different power solutions, the core of the company is still very much gas turbine technology, burning fossil fuels. You can see some of the figures around there, and we also have a very large number of university technology centres that we use around the world to give us that cutting edge advantage in whatever it is that we're looking at, whether it's fuel economy or aerodynamics, combustion technology, whatever it is. But underpinning all of that, a figure that's worth sort of pulling out is we spend about 1.3 billion pounds a year on R&D every single year. So it's not a one-off, every single year, 1.3 billion. And we reckon that at least 2/3 of that is environment related. Okay, it's to improve the efficiency of the products that we make. So, you know, it's quite a significant number. In terms of trends that are shaping our market, well, these are the 3 things that we sort of champion these days. Obviously, you know, our products burn fossil fuels, but there's a growing demand for cleaner, safer power. We're the first to admit, you know, the science and independent science around climate change, so it's our duty to make our products as efficient as possible, and that is the big environmental input from the company. But also things are changing. So in terms of cleaner, safer power, we're pushing SMRs, small modular reactors. These are nuclear reactors. Part of our portfolio is to deliver nuclear reactor cores for submarines, and it's building on that technology to say, well, you can very quickly build a small modular reactor and put these all around the country. So that's an area that we're looking into. Electrification is the big mantra these days. Everything's going electric, as you will know, including aviation. So we might only be a decade away from having the first electric plane flying within Europe. I think it's a long time, if ever, you'll have that going on over the Atlantic, because it's so far to go. But certainly, you know, electrification is coming in. And digital, everything's digital. It's all about data these days. So digital is big, but it's also big in manufacture. So, you know, in terms of the way we actually manufacture materials, like additive layer technologies, things like that. You know, we're looking at the very latest technologies for manufacturing that will also use resources more efficiently and produce less waste. This is our environmental approach. It hasn't actually changed much in about 15 years, and these are the three broad strands that we always talk about. So the first one is about reducing the environmental impact of our products and services. That's the dominant thing for the company. So if you do a life cycle analysis of a jet engine, and you look at it in terms of carbon, then literally 99.9% plus, 99.9% plus is actually in service, product in service. Because if it's an engine, it will sit on a wing, probably up as much as 25 years. And during that time, of course, it's serviced and maintained and there's bits come in and out. But for 25 years, that core module will be burning kerosene. So 99.9%. So if we improve the efficiency of our product just by a fraction of a percent, it wipes out our operational footprint, which is the bit that I'm concerned with. So I don't spend much of my time on the product side, I'm more on the operations, on the factories. But so that's why design of the product is so important. Developing new technologies, so we're really into that. On the earlier slide you'll see the number of patents we take out every year, massive effort into R&D to keep ahead of the curve. And item 3, this is the bit where I come in. This is about reducing the impact of our operations. So if you look at the impact of the company, then way up there it's that product in use. Somewhere here then it's our supply chain, and actually pretty well way down there is my bit actually in our own internal supply chain. That's not to say it's not important though, and we don't do lots of work around all of that. And we have an environmental advisory board which is actually chaired by Sir John Beddington. He's a former climate change advisor to the Prime Minister and to government. And him and a number of other notables steer the company and challenge what we do all the time in terms of how we're applying science, what our position is around climate change, etc., resource efficiency, and the programs we run. So we have a good academic background to support us on that particular journey. So I've mentioned that really aero engines dominate what we do. I mentioned the life cycle part of it as well, but some other interesting things to bring out on that. So we actually make more than half of the world's largest engines that are in service at the moment. But the interesting thing around this from your perspective is that we sell more and more engines now as a whole life package. So in fact the military, in fact in some commercial customers, buy an engine and pay by the hour. So for every hour they operate, they will pay a fee for that. We sell service packages because that's where the money is. We don't make money selling engines. We make money in the way that we maintain and service that for the lifetime of it. And also you'll get improvements. So engines will have modules that are changed every few years. So as we improve combustion technology, whatever it is, the coatings that we have on blades, whatever it is, that will be retrofitted to engines during the lifetime. So an engine never stays the same for 25 years. There's modules coming in and out all of the time. And we've also got in-flight monitoring going on. So literally there's a centre in Derby. If there's a problem on an engine, the centre in Derby knows the same time as the pilot does. So by the time that aircraft lands, it's got a service engineer going there to do whatever needs to be done. It needs to tweak something or replace something. Okay. So this is the the core part of the company, selling power and power by the hour. I mentioned about the footprint of the engine technology. This is an example of how we work across the industry to constantly reduce that environmental impact. You can see a chart here from 2000 of how the efficiency of successive engine developments have improved year on year on year. Of course, it gets harder and harder. This is a very challenging target to meet here, this 30% reduction. And you're always pushing sort of physics. So if you increase the temperature of operation, which is largely dictates the efficiency, so you can operate hotter, be more efficient, but then you start to generate more NOx. So you need combustion technology designed to reduce the amount of NOx, because we've got targets to reduce NOx, fuel efficiency and noise from engines are the three that we go at. And actually in the core of the engine, we have a lot of components in the core of an engine that actually operate beyond their melting point. And the only way they do that is because they have either ceramic coatings applied to them, or we have little air holes put in. We bleed films of air over the aerofoil sections to keep them cool. It acts as a barrier between the combustion chamber and the actual blade. So, so many materials operating in an environment that is hotter than their melting point. So it's a very challenging environment. I mentioned about technology and capabilities for low emission products, and here's an example. This is the small modular reactor I talked about earlier, but we're also looking at things like hybrid systems. So more and more of our products are sold as hybrid packages. In the marine environment, you will have ships that operate in coastal waters burning methane, gas-fired. But then when they go into deep ocean, they'll go into oil or other fuels that are sort of less environmentally friendly from an air perspective, from an air quality zone management perspective. So hybrid is interesting and growing. And another area that we've done quite a bit of work on is fuel cell technology as well. We backed out a little bit a while ago, but we're still keeping the watching brief on fuel cells. I think fuel cells will actually have a future. So coming to my bit, so this is the operations bit I wanted to talk about and share a little bit about our targets and our journey around here. This is a picture of our facility in Bristol. We have 100 locations that we operate globally, and we've got 25 major locations. This one at Bristol is our defence operation, and the whole of that roof there has been covered in PV panels recently. We've been doing that globally, a lot of that going in, so PV is quite a big thing for the company at the moment. But in terms of targets, so these are the targets that we've actually set. We used to set targets of around about 10% every 3 years, but then we realised when you normalise on turnover, a lot of that is delivered by inflation and the growth of the company. So we were doing things and we were making benefits. All of our operations are ISO 14001 certified as well. So the whole of the operation comes under ISO 14001 specification for environmental management systems, and we have Bureau Veritas come in, and we have one global certificate. We have one management system. We used to have 80 certificates from several providers, but we crashed that into one system. So we have one global way of doing all of this. But we challenged ourselves about 3 years ago and said, well, we need to be a lot more aggressive. So we set very aggressive targets for energy reduction, more aggressive ones for greenhouse gas emissions, and obviously you get that by looking at the mix of the power source, okay? So more renewables, and we are actually on trajectory to meet those targets. The two that I get involved with are very challenging because we wanted to reduce the amount of waste we generate by 25%. That's a real big bit to go at, that's massive, 25%. And zero non-hazardous waste to landfill. We have to say non-hazardous because we do have hazardous waste that can only go to landfill. So nuclear waste is an example of that. But there's certain chemicals we use within the company where at the moment the only way for them to be disposed of safely is to go to landfill. There are other technologies available to deal with them. So they're targets that we've actually set. And what's the business case for all of that? And this is where it starts to get interesting, because this is where you will get interested when you're doing this sort of stuff. So if you actually look at the true cost of waste, it's actually a very, very big number. So we generate over 50,000 tonnes of waste a year, solid and liquid waste from our manufacturing operations. That's about £10 million in terms of waste disposal costs of what we pay contractors to dispose of that globally. So it's about £10 million. But if you actually really look at the true cost, because we're using very high value materials, we're using very expensive acids, we're using very expensive metals, okay? Most things we buy tend to be quite expensive. If you actually look at the true cost of that raw material and add that in, forget all the other costs below, we haven't even bothered to look at these additional costs, then you've literally got a 3-figure in the hundreds of thousands figure to go at. So if you start to chase down the targets we've set, you can easily look at 25 to 40 million of saving, and there's obviously potential for much wider application of that within our supply chain. So there's a lot to go at. And this was a piece of work we did about 4 years ago, and we did it because we'd got to somehow engage the board. We were struggling to get the board committed on this. They didn't see it as an important area. They get energy. Energy is easy, you've got good numbers, you've got lots of things you can go at, so you can put your LED lighting in, you can put your PVs in, you can get a fast return, a 12-month return. But you've got to energise the board and say, this is important and these are numbers. When I first put those numbers up, I was told it was a fruitcake. I was actually said, no, they're wrong. And some board members did everything they could to rubbish what we'd done. We said, well, no, actually, we independently did that, but then when you go and you look, you go to the Rapsis world and other people, and you look at the typical percentage of your turnover that could be there available to have, that's the sort of number you're looking at when you're a sort of a 15 billion turnover company. So, so it's quite sensible. That's the sort of number to go. And we had to use that across the company to really energise the company. The other thing that we started to do was talk more about the waste hierarchy. I'm sure most of you will be familiar with the waste hierarchy and seen this. And we'd not really used it a great deal within the company, certainly in communications. And we were really very much down this end here, looking, generating waste, giving it to our waste contractors and pushing them and saying, please do more with our waste. And they're saying, well, there's only so much that you can actually do. But what we'd rather do is not produce the waste in the first place. So the focus of the company now is very much, well, let's go up the waste hierarchy and let's try and prevent that waste in the first place. And there are massive opportunities within the company to actually do that, particularly on liquid waste. We generate an awful lot of liquid waste in the company, from wet processing, whether that's for etching components, chemical size reduction, electroplating, coating systems, just general cleaning and repair and overhaul. We use a lot of chemicals. We have just one site, not far from here, that spends £1 million a year just buying acid. So £1 million a year. So if you can sort of reduce the amount that you're wasting, then there are big opportunities there. So we've been using this a lot within the company to really energise people. And we came up with what we call the Waste Action Programme. That's what I'm going to share with you now. So the Waste Action Programme is a global programme. It focuses on these 4 themes. So we've got systems within the 14,000 model management system about how we manage waste within the company. Okay. Innovation. Innovation is about finding engineering solutions. You see, we don't want to talk about waste anymore. We want to talk about having a commodity. So convert waste into commodity, and let's say, well, okay, if we're generating this surplus material, there's got to be value to it. Don't just throw it out and get it away as cheap as you possibly can. What can we do with it? So we need innovation to do that. So I mentioned earlier about acid. Acid waste is very difficult to deal with, very expensive, but you need innovation there to look at, well, what could we do to regenerate that acid? What can we do to get the dissolved metal out of it? So that some of that acid might have a load of titanium dissolved into it. Titanium is a very expensive metal. Can we work with partners to find technologies to actually take that titanium out? We've got some examples of certain metals where we've done just that. So, innovation is key. Cross-cutting solutions, I spend a lot of my time doing this, where basically we identify a solution, opportunity on a site and think, well, actually, that could apply at lots of sites. So let's make sure we socialise that across the whole of the group. So I have to go in and say to the board, it's best practice. Here's the business case for it. Let's implement it and let's do it across the whole globe. An example of that is cutting fluid. We use hundreds of thousands of litres a day probably across our estate of cutting fluid. So a lot of what we do is machining metal, high value metals. Use a lot of cutting fluid to lubricate that metal while we machine it. That's needed to extend the tool life. It's needed to get the right surface finish. It's needed to get the right quality. A big thing around aircraft components is about stress and about fatigue. So you've got to have a good finish on components. It's got to be almost like a mirror finish. So we use a lot of cutting fluid. We said, well, there are technologies around that could lengthen the life of that cutting fluid. So to cut to the chase, we've identified one technology that was a small medium enterprise company in Sheffield that were looking at this, and it's like a Dyson basically. And it filters the material and basically extends the life by 3 or 4-fold. And we're trialling that at the moment. It's very successful. It's improving quality of the finish as well. So if we can then apply that across the globe, we could save millions, absolutely millions. A big problem I have, and it's not unique to me, but you often find in an engineering context, and particularly in a company like Rolls-Royce where safety is paramount, you will be challenged on any change you want to make. So anything you want to do that changes a process or lengthens the material, so that the time that you use a component, or even substitutes a component, you'll get a pushback straight away, and they'll say, oh no, engine certification, can't do that. We can't recertify the engine. And so, there's always that pushback. So it can be quite hard to get traction on bringing some just basic innovation stuff in. And we had pushback from engineering directors on that cutting fluid issue straight away. And we said, we're not changing anything. The cutting fluid is exactly the same. You're just using it for longer. And by the way, you get a better quality improvement as well. Because the other thing on that big number is the cost of non-quality. So we actually, I won't tell you what the cost of non-quality is because it's quite a big number. But, if we could just make conforming parts every time and not scrap stuff, just think what the saving will be there. And improving this cutting, using this fluid, is part of that. We're getting better quality and less rejects. Okay, so it's a win-win situation. But the other thing is site-based improvement. So, it's people at a local level who know what they're doing and know what the opportunities can be. They're the best people to identify it. We got very frustrated trying to really energise people. And we were using environmental professionals, practitioners to do this. It wasn't working. We said, no, we've got to mobilise the people who are actually out in the patch to do this. So we said, well, what is the scope of the programme? So you've got the process in the centre there, you've got your usual inputs and outputs. We said, no, we are totally focused on just the raw materials that are going into these processes, and then what is coming out of that by way of unused material or by any waste that's generated. So, very tightly constrained. And then we developed a load of toolkits and provided training to our employees around this. So every single site now has a resource efficiency manager. I sort of lost count number of times for years. I actually said, until you get a resource efficiency manager on every site, we're not going to make any progress. So we now have resource efficiency managers in place. We have champions, and we have these processes now that are getting embedded for businesses to start to identify their waste, to map their wastes. The first thing you've got to do on resource efficiency is map the waste. If you don't map it, then you haven't got a chance. So you've got to start mapping that waste. Prioritise the opportunities. Obviously, then you've got to develop the business cases around all of that and implement the solutions. So we've spent a lot of time developing these tools, applying them, and they are global. So it's one way of doing it. Everything we do in the company is about doing it one way, doing it the same way everywhere that you go. And it's where to focus. So you might struggle at the back to sort of read some of these, but this is really an example of the way we go about this. So every business now has a Pareto of their waste. So they have to identify all their wastes. I get a monthly report globally from every business as to what their waste streams are and how much they're putting out of the system. To do a Pareto, and then against that say, well, what are the top 10 initiatives that you're going to focus on in this next 12 months and drive those to execution. And here you can see, typical range in an engineering company like us is acids and alkalis. We've got lots of metals, of course. Packaging. Oh, packaging is a nightmare. Backdoor packaging. We talked about. I wish we could do something on packaging. It's a nightmare. Inbound packaging is growing all the time. You know what it's like when you get things from Amazon and stuff like that. It's a nightmare. We get that by the truckload, literally, and it's growing. And again, push back on that. Oh, you've got to keep the parts preserved. We can't have damage. So we can have components coming, and it's literally like a lucky dip box. You open the box, there's bubble wrap. I literally opened a case this size recently in a shop, and we pulled the bubble wrap out. It was 100 metres long, the bubble wrap. And then underneath that, there was a big thick layer of foam underneath it as well. And we have components coming in boxes, in crates. So you've got wood with metal fasteners, with foam glued on the inside and loads of bubble wrap around it. It's just crazy. A lot of those items are a single shipment. They only go one way. They never go back, and they go into a landfill. So packaging waste is an absolute nightmare, and really policy, we need policy and regulation. Well, actually, if we could actually enforce the essential use regulations in the UK, that would be something. But there's a lot we need to do around packaging. And then we've got lots of complex waste like sludges and filter cakes. We've got blasting media and grinding waste. And of course, the problem is a lot of those materials are quite inert, but they're contaminated with metals which are not inert. So if you're working with nickel and titanium, things like that, these become carcinogenic in small amounts. So they become hazardous waste, and so on. And then against this here, start to think, so what are the things you're going to do? So process chemicals, optimise their use, look at slimline forgings, near-net shaped forgings. So we don't buy massive forging and then machine and load off. We've had purchasing people cut a deal with suppliers and send in a bigger forging because it's cheaper. Well, okay, well, that's a great deal, but then we're going to spend 5 hours machining it down to the size we really wanted it to come in the first place. And then we've got all that metal. Closed loop recycling on supply take back on packaging, better labelling of waste, coolant life extension, and so on. So there are loads of things there, and these are all opportunities that you see at every single site that we work on. But what is the circular economy? And I think one of the problems that we actually have is defining it within the company and getting everybody to agree what is sustainability, what is circularity. Most companies I still talk to still have yet to really define what sustainability is for them. There are still some companies in the world that will not use the word sustainable. Royce, it took a few years for us to actually start to use that word, sustainability. But it's all things to all people. But certainly, we want to move away from this linear economy to this circular economy. And certainly in our company, when we train our engineers, our designers, our material spec people, This is the thinking now that is going into all of the processes we have. And we're largely, you can imagine, dominated by quality, we're dominated by lean and all Six Sigma and all these sorts of processes. And the trick is about embedding all this thinking into those decision processes to make sure that we start to generate the right sorts of decisions. I want to show you a short video. This is the best example I've got really in the company, an example of circularity. And this is a revert program where we take high value metals and actually have a closed loop recycling system. So all the contracts that we have these days with our suppliers for these certain metals that you'll see, they have to sign up to a closed loop system. So any waste that they generate in manufacture, production of the raw material coming in, that would be ingots and bar stock, anything that we generate in machining, anything that we generate in terms of repair and overhaul when we take components out of engines, it all goes back into this supply chain. The idea is to keep that within the global supply chain. We don't want titanium ending up in golf clubs. We want to keep it within the sector. And the trick, the focus on all this, is to keep it at aero-grade material. Lots of people will have recycling schemes, but they're downcycling all the time. So to keep that purity there, and keep the aerospace quality there, you've got to have a totally closed loop system. You can't afford any contamination in there whatsoever, or somebody else having a bit of titanium and throwing it in, because it won't be aero-grade material and it needs full traceability.
Can I ask you, do you think that the suppliers changed that purely because of your pressure and everything, or was that a risk for Rolls-Royce to lose the suppliers?
The suppliers changed because we told them to. The initial driver behind all of this was business continuity, was supplied materials, so critical materials that, there's only a limited supply in the world. There are a number of companies going for those materials, prices going up, price volatility. So we've actually got people whose their life in Rolls-Royce is basically buying and trading materials and stockpiling them and hedging future. Just as we do in currency, we spend a fortune or a lot of time hedging on currency because all of our products are sold in dollars, but a lot of our costs are in pounds and euros. So we have a massive we have billions of pounds worth of hedging. And they do just the same on commodities. And that's about price, obviously, but increasingly it's about the volatility in markets and having access to those materials, because some of them are in incredible short supply. There are certain alloying elements we use which enable us to operate those materials towards their melting point and beyond, where you might only have 100 tons of supply in the world in a year. So, you can be talking of very small amounts, particularly of the rare earth materials. And so that's why, that's why it started, but it's grown into be quite a big thing for the company. And certainly people like DEFRA and lots of other groups often use this as an example of circularity. Are we getting there? Or... is that on the internet or on the... It's actually on the... You copied it off the memory stick. It is available now, yeah. The link is in the PowerPoint for that, but it depends on what your signal's like. That one there. You had it before though, didn't you, on the MP plane? Oh, yeah, sure.
Did you have some targets to reduce the use of raw materials at the end of the process?
Yeah, I mean, that's all about, obviously, efficiency of manufacture. So, yeah, all of the businesses for critical materials will be looking at all the time, how can you actually reduce the amount of material that you're using. So, you'd sort of think by now we've probably sorted all of that for some of the materials, but we haven't. So the example I gave you about net size forgings, there's still a lot of opportunity to buy in forgings that are closer to size. There's more of a move to powder deposition, metal matrix, 3D printing, that sort of thing. So it's in the early days, really, in the engine components, the airlines are using it more and more around fuselage items and stuff, and non-stress items. But we are seeing more and more 3D components coming in now as well. And obviously, they're very efficient because you're just using the powder that you need. So that's great, and you're also cutting out lots of additional steps as well. But the problem with all of those is having a system that gives you those wrought properties.
Has finite resources, and the demand for them is increasing. Reducing our reliance on virgin materials is an essential part of a sustainable future. In the aerospace industry, we have a particular responsibility. Rhenium, hafnium, nickel and titanium are just some of the exotic metals needed to make the alloys that go into today's advanced aero engines. Over 20,000 tons of these alloys are used each year by Rolls-Royce, equivalent to 2.5 Eiffel Towers. That's why it makes good business sense and good environmental sense for us to recycle as much metal as we can. Every one of our manufacturing and repair facilities in over 100 locations around the world is part of a global recycling program we call REVERT, where we recover, recycle and reuse waste materials. Over the past decade, we have developed processes to remove coatings, segregate materials by alloy type, and remove any contaminants. Unserviceable engine parts and waste metal from machining and casting processes are recovered and melted, enabling them to be returned to aerospace-grade alloys and reused to make new engines. Almost half of a used aero engine can now be safely recycled to a standard where the quality of the recovered material is so high that the metals can be safely used again to make a new engine as part of a fully closed-loop system. Through REVERT, we save 300,000 megawatt-hours of energy each year. That's enough energy to power 27 million homes for a day. It also saved 80,000 tonnes of carbon dioxide compared to using virgin material. That's the same amount of CO2 emitted if a car travelled around the world 13,000 times. REVERT is making a big difference. We reduce our demand for raw materials. We use less energy. We produce fewer emissions. And we save costs. Rolls-Royce, pioneering the power that matters.
There, so there's a figure there of 50% of an engine can now be reverted and reused in the aerospace industry. So probably about 85% of the engine is recycled. There's always bits that you can't, that get contaminated or whatever. So 85% can be recycled, but now up to 50% of the engine can actually be reverted within the aerospace industry, aerospace grade. So that model is what we're now trying to repeat on lots and lots of other areas of the company. That's really sort of set the benchmark for us. I've got 5 minutes. Just okay. Very quickly then. A couple of slides here on drivers and sort of challenges. Obviously, business continuity. That's the main driver in everything that we do. Because we've got finite resources to go at, and as you can see, we rely on some exotic materials as well, and there's only a limited supply of those. There's plenty of crustal abundance, but there's not so much available in the marketplace to go at, and they always tend to be in rather difficult areas of the world as well, very sensitive areas of the world. Cost reduction drives everything, and as I've said earlier, it's about reducing the impact in terms of how much you can recycle, and also reverting more and more of that within the actual product. In terms of challenges, I think language is a real challenge. I mentioned earlier about definitions of sustainability and circularity. It's not always a common language for people. People struggle with it. So I think for most companies, it's about, it's defining for yourself what is sustainability. What does it mean to you? What are you going to focus on? Because you can't do everything. Data, lots of exclamation marks. Data drives me nuts. We spend so much time collecting data globally. We have fancy electronic systems to do that. We spend so much time arguing over whether the data is right or not. And I spend a lot of time with people trying to say the data is good enough to work with, go make decisions, do things. Okay, refine it for the business case, but the big number, the 50,000 or whatever it is good enough for you to know where your key waste streams are and what you should be focusing on. So data can be good, but it can also be counterproductive as well. It is a bit of a bane of my life. Waste mapping, again, getting businesses to do waste mapping, it's time consuming, people need to be trained to do it, they're often reluctant to do it. Business case payback, things that will pay back in under a year, you can pretty well get through. Financial accountants, 2 years, not so sure, 3 years, don't even go and ask. So it's that 1 year payback. There's lots of short-termism in the industry around all this, there's lots of other business priorities, Brexit's quite a big one at the moment. Cross-function working. What we've found in the Waste Action Programme is that to really start to make significant headway towards that 25%, you've got to talk to a lot more people than we did many, many years ago. You've got to talk to the designers for the front end, you've got to talk to the purchasing about the contract, you've got to talk to the waste contractors, the legal people. You know, there are so many different functions that you need to bring on board to make it a successful campaign. Terms and conditions with suppliers, that's something we're starting to work on now. We haven't been good in the past at saying to suppliers how they should ship material to us, that they should take material back from us. So, you know, more and more is needed on all of that. Behaviours and culture, behaviours and culture is, I always call it the handbrake on the system. We have dreadful behaviours within the company. We're not the only one, but you go around many companies and look at the poor segregation techniques. You can train people, you can put bins out, and people are still throwing the sandwiches in a skip load full of titanium. You know, and we've got lots of examples where you've got material worth thousands, we're only getting hundreds for it of pounds because it's contaminated when it arrives at the disposal or recycler facility. So, you know, behaviours and culture is a massive thing. Talking about waste, not as waste but as a commodity is the other thing. So as I did here as well, reflecting earlier, people have touched a few times about regional variations. So regional capability and capacity is an issue. Give you one example, we generate 3,000 or 4,000 tonnes of foundry sand in Norway. In Norway everything's expensive, transport's expensive, waste disposal is expensive, it's hazardous waste. We managed to put a business case in to put a recycling plant in that recycles over 90% of the sand and reuses it. Over in America, where the same waste is inert, apparently, and sand is cheap, transport is cheap, there's a massive landfill nearby, can't get it to work. You know, cannot get it to work. And we have that sort of thing to deal with all of the time. Just finally, I think getting people on board is important, and there are some things which look a bit small beer. Plastic is good at the moment, so you can ride the wave of plastic. You know, it's very topical in the company. We get lots of questions around plastic. Costa cups is another big thing within the company. We've launched a campaign 3 or 4 years ago to reduce the use of paper cups. This is a cup that I brought into the company. Behaviours are interesting. So we started to give people a discount if they used one of these cups. So they got 10p, then they got 15p, then they got 20p. And we couldn't get above a 20% recycle rate. We changed it a few weeks ago and said, right, we're now going to give you the drink, you buy the drink, but if you don't bring a cup, you've got to pay 20p for the cup that you're going to have it in. It's gone to 55% in 2 weeks. It's like the plastic carry bag sort of thing, isn't it? And although this is, in a sense, small beer, it's the behaviours and culture that interests me. Same with paper. You know, printing on paper drives me mad. So secure printing, things like that. Again, it's not a lot, but you know, it's important in generating the right behaviour. So here, in the office where I'm based here, you know, we said, look, you know, we generate 80 tonnes of waste paper a year in the paper that you've not collected. That's paper every day that people print that never go and collect. So that's why we're getting secure printing coming in. It's not a lot in the scheme of things, but it's that behaviour and culture that's really, really important. And we take every opportunity we can to try and put these things in front of people. Finally, you know, we keep exploring what we can do. One thing just I thought I'd mention just to finish with is composites. So we're moving a lot more to carbon composites in the aviation industry, both in the air engine and in the fuselage of aircraft. Boeing and Airbus both now make aircraft with composite fuselages. They're great because they're lighter, so it's more fuel efficient in life. You can pressurise the cabin to a greater pressure, so it's a better travel experience. But what do you do at the end of life with all of that material? Because at the moment, there are very few facilities available to recycle the carbon fibre. It's a very energy intensive process, and we're about to use some more carbon fibre on our sites. I contacted the only recycler available to us, and they won't take any more at the moment. They have warehouses full of it. Because at the moment it's all downcycled. You can't get the carbon fibre out in the length it went in at to reuse it, so it all gets downcycled. There's only so many park benches and bollards you can make with carbon fibre. So you know, they're the sorts of challenges that we face all of the time in the industry. We want to do more, but there are, you know, real technical constraints to deal with. I'm sorry I've raced through all of that. There's lots I could talk about. I just want to try and give you a bit of a sense really of how we're approaching circularity within the company, resource efficiency, whatever you call it. But some of the examples are just some of the challenges and some of the things we're dealing with, but also some of the things that we have yet to find solutions for. Thank you.